Dear learners, today, the focus of my presentation is testing of hypotheses. Let us first try to understand how to formulate hypotheses. 1. Null hypothesis. H0 represents the default or no effect assumption. The null hypothesis, denoted as H0, is a statement that suggests there is no significant effect, difference, or relationship in the population. It often embodies a default or status quo assumption that researchers aim to test against. Example H0. There is no difference in the average scores between students who receive traditional teaching methods and those who receive online instruction. 2. Alternative hypothesis. H1 posits a specific effect or relationship. The alternative hypothesis, denoted as H1, is a statement that proposes a specific effect, difference, or relationship in the population. It represents the researcher's hypothesis or the assertion they aim to support with evidence. Example H1. Students who receive online instruction have significantly different average scores compared to those who receive traditional teaching methods. Select significance level, alpha. The significance level, denoted as alpha, is a critical parameter in hypothesis testing that determines the probability of making a type I error. It represents the threshold at which researchers are willing to reject the null hypothesis. Commonly used values for alpha are 0.05, 0.01, and 0.10, indicating a 5%, 1%, or 10% chance, respectively, of incorrectly rejecting a true null hypothesis. Example, choose alpha is equal to 0.05, indicating a 5% probability of committing a type I error. The chosen significance level of 0.05 indicates that the researcher is willing to accept a 5% chance of incorrectly rejecting the null hypothesis when it is actually true. This means that if the study were repeated many times under the same conditions, the researcher would expect to make a type I error, rejecting a true null hypothesis 5% of the time. Decision rule. When conducting statistical tests, the researcher compares the calculated p-value to alpha. If the p-value is less than or equal to 0.05, the researcher rejects the null hypothesis. If the p-value is greater than 0.05, the researcher fails to reject the null hypothesis. Type I and Type II errors in hypothesis testing. In hypothesis testing, researchers face the risk of making errors when drawing conclusions about the population based on a sample. These errors are categorized as Type I and Type II errors. 1. Type I error, rejecting a true null hypothesis. Symbol alpha, alpha. Explanation. Type I error occurs when the researcher concludes that there is a significant effect or difference when, in reality, there is none. Example. A drug testing scenario where the null hypothesis, H0, states that the drug has no effect on patients. Type I error, concluding that the drug is effective when, in fact, it has no impact on the patient's condition. 2. Type II error, failing to reject a false null hypothesis. Symbol, beta, beta. Explanation. Type II error occurs when the researcher fails to detect a real effect or difference that truly exists in the population. Example, testing a new treatment for a disease where the null hypothesis, H0, states that the treatment has no effect. Type II error, concluding that the treatment is ineffective when, in reality, it has a positive effect on patients. Practical consideration. Imagine a criminal trial as an analogy. Type I error, incorrectly convicting an innocent person, false positive. Type II error, incorrectly acquitting a guilty person, false negative. Choose a statistical test. 1. Identify the nature of the data. Example, a researcher is investigating the difference in exam scores between two groups of students, example, Group A and Group B. Data type, continuous data, exam scores. 2. Consider the research question, example, Research question: is there a significant difference in exam scores between Group A and Group B? Statistical test: an independent sample t-test is appropriate for comparing means between two groups. 3. Number of groups or variables. Example: a study examines the effect of 3 different teaching methods on student performance. Number of groups. 3. Statistical test. Analysis of variance, ANOVA, is suitable for comparing means across more than 2 groups. 4. Relationship between variables. Example: investigating the correlation between study hours and exam scores. Data type: continuous data for both variables. Statistical test: Pearson correlation coefficient to measure the strength and direction of the linear relationship. 5. Experimental design. Example: a repeated measures design where the same group of participants is measured under different conditions. Statistical test: repeated measures analysis of variance, RM ANOVA, to assess changes across different conditions. 6. Data distribution. Example: assessing whether the distribution of a variable is significantly different from a normal distribution. Statistical test: Shapiroval test for normality. 7. Nature of comparison. Example: investigating the difference in proportions between two independent groups. Statistical test: chi-square test for independence. 8. Scale of measurement. Example: analyzing the difference in average response times across different conditions. Data type: continuous data with an ordinal scale. Statistical test: Driscoll-Wallace test, non-parametric equivalent to ANOVA, for ordinal data. 9. Consider the assumptions. Example: testing the difference between two related groups when the data is not normally distributed. Statistical test: Wilcoxon sign rank test, non-parametric equivalent to paired t-test, for non-normally distributed paired data. Thank you. Don't forget to subscribe to my YouTube channel Education and Teacher Education at Shokin Bilal.